Hello everybody. A couple of minutes ago I have recorded the video about the flat roof systems. Basically we had a reinforced concrete strip foundation. Let me push it a little bit up. We have a reinforced concrete strip foundation and on top of that reinforced concrete strip foundation we put a reinforced concrete column, and right next to that reinforced concrete column between the ground, underground, and our basement floor we have a barrier, a retaining wall, which we call as a reinforced concrete basement wall, and the reinforced concrete slab floor is being carried by the reinforced concrete basement wall and the columns that we have there. And above that column, after the ground level, we place a base plate, and on top of the base plate we place a column, and the column carries main beams carry the secondary beams and the cantilever beam on left hand side of it, and there is a steel trapezoidal sheet topping concrete, and the roof is going to be a flat roof. And what we want it to be a normal flat roof system. That's why on top of the topping concrete we place a vapor barrier. We cover the vapor barrier with thermal insulation. We place slope screed. On top of the slope screed, we cover the slope screed entirely with a waterproofing. On our parapet wall, the waterproofing and the vapor barrier are adhered onto each other. And now we can leave the waterproofing as it is, or in order to transform our flat roof into a usable terrace, what we need to do, we need to cover it with a screed, and we need to adhere a proper finishing material, not like natural stone, ceramic tile or concrete tiles, with the help of a mortar or a glue, like a ceramic glue. We need to adhere the finishing material onto the screed that we place above the waterproofing. And of course, before doing all these, the first thing that we do is constructing a parapet wall to our building. The thermal insulation coming from the external walls of our building are going to continue until the top of our parapet wall as well. And on the inner side of the parapet wall, we again need to use a thermal insulation. Maybe we can extend that thermal insulation until there. So in order to do that before placing the screed, maybe it will be better. Let's draw it like this. Before placing the screed and the mortar and the finishing material, it will be better to cover the inner side of the parapet wall as long as we can. And in order to prevent the top of the parapet wall to be exposed to rain, we close it from the top by the help of a hat, which we call a coping, a watertight continuous element. And now what we will do is we are going to cover this building of ourselves with a roof system as well. And now I want it to be a pitched roof system with a slope of let's say 30%. Okay, or let's make it 50%. Let's make it as sloped as possible. And in order to show you how we give slope to a roof, I will do something very simple. This is a very simple ruler. Okay, but before using that ruler, let's extend our sheet of paper. I'm going to stick a piece of paper on top of my drawing right here. Now I obtained enough space to draw my roof system there. Here is the tape, and let's stick a tape to the other side as well. Okay, now I've got lots of free space for my drawing. Okay, what I will do is this. I'm going to measure from here to there 4 centimeters. It doesn't need to be scaled. Okay, it is 4 centimeters. And I want my roof to be 50%. That's what I want. Okay, 50% means that in each 2 units you move to this side, you need to increase 1 unit in height. Okay, or if this is 100 centimeters here, this is going to be 50 centimeters. Now I make it 4 centimeters on this side, so I need to go up of around 2 centimeters. Okay, what I will do, I'm going to turn my ruler upside down and I'm going to mark 2 centimeters here. And when I combine those two lines with each other, that's going to be the slope of my roof. Okay, we'll come back to that slope, but before doing so, the first thing that I want to do is I want to extend it slightly up. Okay, let's make our roof, let's carry our roof slope line there, and let's accept that part to be the downside of my rafter. Okay, so my rafter will be carried by my purlins, and my purlins will be carried by roof studs. You know these terms from the lectures. Okay, I will explain what they are in a couple of minutes once more. But what we will do is right on before placing the steel trapezoidal sheet and before covering the steel trapezoidal sheet with topping concrete, on top of my main beam, I place a steel profile, which is probably going to be an RHS, rectangular hollow section. Something like this. This is in fact a small column, a special column on which we are going to place the purlins. And this thing, let's put an arrow, this is our roof stud. It is an RHS, which is, let's assume, 10 by 10 rectangular hollow section. Of course, steel rectangular hollow section. That's right, RHS, steel rectangular hollow section steel. And on top of our rectangular hollow section steel, what I will do is I'm going to place again a hollow section profile. But this time, no, not but this time, it is directly standing on top of my roof stud. Or I changed my mind. Okay, I don't want it to be a rectangular hollow section because in the lectures I told you that if you want to pass a span using an I-shaped section, I-section steel profile is better. Let's use it. Here is a small steel I-section standing like that. It's a beam now. Okay, but it's a beam which is going to carry secondary beams on top of it. It's a special beam which is placed specially for our roof system. That's why it is going to have a special name, which is going to be a purlin. Is it going to be any purlin? No, it's the purlin on the lowest level, so we can call it as a sub-purlin. Sub-purlin. Okay, or eaves purlin. Doesn't matter. It's the lowest purlin in my roof, and I like to call them as sub-purlins. And on top of my sub-purlin, what will I do? I am going to cover, or I am going to place on top of my sub-purlin my rafters. And what are these rafters made of? Those rafters are made of steel again, and they are also reinforced concrete hollow section, but the size of them is not 10 by 10. Let's draw, just a second, let's erase some part of it, and let's draw here a dashed and dotted line to represent that it continues up. Okay, somewhere here I have my mid purlin, and somewhere more on top I'm going to have my ridge purlin. Okay, and now this is my steel rafter, which is a secondary beam, okay, which is a steel RHS of 5 by 10 in section size. Now it's okay. Now what I'm going to do is I'm going to cover let's take some colorful pen. I'm going to cover the top of my steel rafter with a wooden board. Let me hatch it and make you see it more clearly. Like this. That's a roofing board. That's a board with a thickness of 2 centimeters. Okay. Let's stop working on the roof for a while and let's try to construct a wall here. I need to have a wall because I want my attic space, this is my attic here, to be a warm place in winter conditions and cool place in summer conditions. I want it to be a usable space. In order to turn it into a usable space, I need to prevent coldness or hotness to arrive inside that space. And in order to do that, I need to have a wall, of course, here. And here is my wall. I'm going to use a lightweight steel structured wall here. I'm going to put a lightweight steel U-profile there, and I'm going to put below my rafters again a lightweight steel U-profile, and I will place my lightweight steel C-profiles inside them, and I'm going to cover both sides of it again with boards. And what I will do inside it, I'm going to fill acoustical insulation. And what I also am going to do is this. I'm going to extend the thermal insulation here until to the bottom of my roofing board. Okay, this is the thermal insulation coming from the external wall of my building. Okay, and what I will do, you know that here we have got a wooden button, a substructure which is going to carry the finishing material of the external wall, which is a cold wall system, which can be ceramic tiles, wooden tiles or wooden finishing, or it can be even a fiber cement board finishing material as well. Here are those buttons. Those buttons continue until the top, until there. Okay, here is the button. And the finishing material also continues to the top. And this space, let's hatch it with orange as well. That space is the ventilation space. So what I will do, I'm going to leave a gap here. And air, fresh air, this fresh air is going to enter from there and it's going to escape from here, of course. Okay. And now I have my closed side wall for my building. If you want, you can fill here entirely with thermal insulation and you can continue this board until the top. But don't forget that those boards are going to enter inside the rafters, so they do not have a flat top line. Okay, there is going to be tooths on that roofing board, on that not roofing board, on that board. Okay, so here is the boards that I'm talking about. Okay, now what I need to do, I need to generate a space for thermal insulation in my roof system as well. What I will do, I'm going to use the same method that I used in my external wall. I'm going to put buttons here, flying buttons. Of course, they cannot fly. Okay, I draw them more thick than they should be. They deserve. Okay, here are the buttons that I'm talking about. And Professor, how are they staying there if you ask? You remember these pieces that you see there? Those are brackets. L profiles, you remember. Okay, with brackets, we anchor them to our steel rafters below. Like that. Okay, from here let's put some dots in order to represent that they are screwed to each other. And this is going to give me the possibility of using thermal insulation here. A continuous thermal insulation, which is not interrupted by any button, because the buttons are going over them. Okay, like that. The only thing which interrupts the thermal insulation are these brackets there, but they are probably made of lightweight steel. That's why they are very thin and they are not going to affect the overall thermal performance of your roof system. And on top of this button, what you will do is, before doing that, let's remind you that right here we cover the top of our thermal insulation material with a permeable membrane, okay, in order to prevent the risk of making our thermal insulation material get wet. And of course, below the thermal insulation, we firstly cover the roofing board with a vapor barrier. And then it is now time for covering my buttons with an extra roofing board. Here is that roofing board. This roofing board is really a roofing board on which it's going to carry a thermal insulation material. And what I will do now, I'm going to turn the wooden board to here, and I'm going to screw one to this button, and I'm going to, with a bracket, tie it to the steel rafters, and I'm going to open holes here in order to let fresh air to enter there. Okay, fresh air entrance. Fresh air entrance there. Let's cover our roof with our roofing material now. Before putting that roofing material, let's put here an extra waterproofing, maybe a permeable membrane or maybe a bituminous membrane. Any type of waterproofing you can use there, because there isn't any condensation risk anymore, because on top of the thermal insulation you lift a ventilation space and you protect your thermal insulation with vapor barrier and with permeable membrane on top of it. Okay, and now it's time for placing our roof tile buttons. They are going to hold the roof tiles, very small 1x1 or 1x2 size of wooden buttons. And starting from the lowest level, let's put a small button here as well. What I will do is I am going to cover my roof system with roof tiles, which are schematically shown like this. Okay, but let's look at the first one in the row, because what will I do here? What will I have there? On top of the roofing board and below the thermal insulation, I'm going to place here a gutter, and that gutter is going to be tied to a downspout, and that downspout is going to go like this and reach to the external wall of our building. It's going to be tied to our external wall. Okay, these are downspouts of my building. Okay, so they are going to continue until the ground level like this. They are going to pass all this way, and when they reach the ground, they will be left. They are going to drain the rainwater coming onto our roof to the ground level. Okay, let's write the layers and finish this thing. What do we have? Firstly, we have a board. On top of the board, we have the thermal insulation which is standing in between the buttons, or not between buttons, under the buttons. We didn't place the buttons right on top of the board. And between the board and the thermal insulation, what do we have? Okay, we have the vapor barrier firstly, and board is here. And above the thermal insulation, what do we have? We have the permeable membrane. Over the permeable membrane, we have the ventilation space. And over the ventilation space, I have got my roofing board. Over the roofing board, I have my waterproofing. And I finish the roof with roof tiles. And what is this thing here? That's the gutter. And this thing that we have there is the roof stud. Oh, excuse me. I don't know what I was thinking about. It is a downspout, not a roof spot, of course, down spot. One last thing, of course, this first roof tile is going to come a little bit over the top of the gutter. Okay, so the raindrops dropping here are going to flow down and fall into our gutter. In order to make it sure that raindrops are going to fill there, the gutter is going to, the roof tile is going to be placed a little bit inside the or over the gutter. That's all. So you have to complete this wall section with a pitched roof like this one, which has a slope of 50%. See you later.